After I ordered my EG4 18 kPV inverter, grid boss, and REC solar panels from Signature Solar, I got started installing everything except the panels right away. I split my project into two stages so I could quickly benefit from a partial install and get comfortable with the EG4 systems while I worked on designing and building the PV frame. In this stage, I set up a solid battery backup for all my critical loads by installing the grid boss, inverter, and a 32 kilowatt DIY battery bank. I built my own battery to save money while still getting a decent amount of storage. I used a wireway to neatly route most of the wiring between the equipment, cutting down on the amount of conduit needed. This keeps your wiring workspace clean and looks great once the cover is on. For the 18 kPV and grid boss, I used a 10 by 10 inch wireway with a 5-foot length. The 18 kPV came with a cardboard mounting template, making it super easy to drill and mount the bracket. Before mounting on the wireway, open the necessary knockouts on both the inverter and grid boss. With the inverter mounted, trace the knockout holes on the wireway. Then remove the unit so you can open the holes there. I recommend using a knockout punch for this step. I used a hole saw because I didn't have a punch on hand. Be sure to install the right size knockout bushings to protect the wiring. I used the same process for mounting the grid boss. Next, connect the 18 kPV grid lugs to the hybrid breaker on the grid boss, making sure to use the proper torque specs. I torqued all connections before going live. The other connections on the 18 kPV are for battery, BMS comms, grid boss comms, and PV. The load and generator connections go directly to the grid boss. For the battery, I used EVE MB31 314 amp hour lithium iron phosphate cells, 32 cells in a parallel series setup to double my capacity while only needing one 16S BMS. Yes, troubleshooting a bad cell in a parallel configuration takes a bit longer, but the savings made it worth it. I used pallet straps to compress the cells between aluminum plates, which is important for extending the cycle life of prismatic cells. Clean setup was achieved with 8-hole bus bars, and I added a 1/4 inch PVC sheet as a protective shield over the battery terminals. I went with the JKBMS model JKPB2A 16S 20P for successful closed loop communication with the 18 kPV. So far, it's been reliable and even has an LCD screen that shows battery status and charge-discharge details. This is handy for checking the state of charge from a distance without needing to view the inverter screen or open the EG4 app. Next up, I'll be building the ground mount solar panel frame and installing the panels. Thanks for watching. I hope you found this video helpful.